Hello friends, today I will take a new topic of alkynes. You see alkynes, these are the unsaturated hydrocarbons having a triple bond between carbon and carbon and whose general formula is CnH2n minus 2 where n is the number of the carbon atom. If we take N2 that is carbon atom 2, then we get a formula C2H2. This is the simplest alkyne in hydrocarbon, which is known as the ethyne or acetylene. In my last videos, where I discussed you hybridization, I explained you structure of the ethynes. Now, in the case of the ethyne, say carbon having two sp hybridized orbitals and the two p hybridized orbitals. One sp hybrid of the one carbon atom overlap with the sp hybrid of the other carbon atom, overlapping head to head, that form the sigma bond. So first bond is in the center, that is a sigma bond. Now other sp hybridized orbital of the carbon overlap head to head to the hydrogen atom, forming one sigma bond. In the same way, other carbon atom also form sigma bond. Now the most important thing is p orbitals. See, two unhybridized p orbitals are there, and these p orbitals they overlap sidewise to form the pi bonds. Two pi bonds. See here, this is the sidewise overlap. This is the sidewise overlap, and they form the two pi bonds. That is, two unhybridized bond overlap sidewise to form the pi bonds. So we say, in the case of the ethyne, one is sigma bond, and on either sides, two pi bonds. Now it is very interesting how this pi bond arrange themselves around the sigma bond. So say if two pi bonds, they are front and back, and second is below and above the sigma bond. So it forms a cylinder-like structure, that is cylindrical pi electron cloud around the sigma bond. So it is very interesting. Say two pi bonds on each other. So if one pi bond is up and down or up and below of the sigma bond, and second is before and the after of the sigma bond, it forms a cylindrical pi electron cloud along the sigma bonds. Now, so we say that in the case of the ethyne, three bonds are there. In the center it is sigma bond and two pi bonds on other side of the sigma bonds. So pi bonds, actually it is a cloud, cylindrical pi electron cloud around the sigma bond. Now most important thing, the distance between the carbon-carbon triple bond is 120 picometer, while the carbon-hydrogen is 106 picometer, and an angle between carbon, hydrogen and carbon is 180 degree. it means it is a linear molecule. And the strength of energy of the triple bond is about 823 kilojoules per mole. And here it is very important thing. Strength of the energy of the triple bond is 823 kilojoules per molecule, and it was found that it is more than the 681 kilojoules mole in the case of the ethene and 348 kilojoules per mole in the case of the ethene. So, strength of the energy of the triple bond is more than ethene and ethane. So, we say that greater energy is released in orbital overlap in triple bond formation. Again, listen. Strength, that is energy of the triple bond, is about 823 kilojoules per mole, and the energy in the case of the ene, that is ethane, is 681 kilojoules per mole, and in the case of the ethane, it is 348 kilojoules per mole. So here energy of the triple bond is more than the ethene and the ethane. So we say greater energy is released in orbital overlap in triple bond formation in the case of the ethyne. Now if we consider the bond length of the carbon-carbon triple bond is 120 picometer. In the case of the ethene, it is 134 picometer, and in the case of the ethane, it is 154 picometer. Now here we see that in the case of the ethyne, the distance is more or less than the ethene and the ethane. Now we see that in the case of the ethene, double bond is there. Now for the formation of the second pi bond, the carbon-carbon atom, they come more closer to each other to decrease the distance of the carbon-carbon triple bond. So we say that it is a linear molecule and has no steric hindrance, so they do not show geometrical isomerism. So today I explained you alkynes and the structure formula of the alkynes. In my next video, I will explain you preparations and the chemical properties, physical property of the alkynes. I think the structure is very clear to you. If you like my videos, please share and subscribe. Thanks very much.